Okay, let us have a look at what Wikipedia says about open close principle. The open close principle states software entities, that is, classes, modules, and functions, should be open for extension but closed for modification. Now, you might be scratching your head trying to understand what this really means. Let us try to understand that with an example. Say, a requirement is such that we need to create a custom sorter class that is capable of performing insertion sort as well as merge sort according to our needs. So, say sometimes we need to perform insertion sort for a list of items, and sometimes let's say it's a good fit to perform merge sort on the same list, and we need this custom sorter to kind of handle this dynamically. And how would we go about implementing such a custom sorter class? Well, I have a list of 5 integers, and I am building a custom sorter, and I'll build this custom sorter in such a way that I pass in a string as an argument, and if the string is basically insertion sort, I perform insertion sort logic here, and if the pass string is merge sort, I perform merge sort on the pass array, and that would be my approach. It works. I code it out and I go home. Well, what could go wrong with this approach? Try to pause this video and think about why this would be a bad practice. Now, here's a twist in the tale. Let us say the product manager the next day comes and tells you that we no longer need to support insertion sort. So please take it out. And instead, we'll be supporting quick sort now. So, how will you modify the code to incorporate these new changes? Now, in order to incorporate the new changes, we'll have to modify the existing sort method, and we'll have to remove the insertion sort logic, and then we have to add the quick sort logic, and similarly, if new requirements pop up tomorrow, we keep modifying this sort method repeatedly. So we keep rewriting code and we keep modifying existing code. So this would be a nightmare in order to maintain this custom sorter class. And also, you can see that we're only adding the quick sort method, and even though we are only doing that, we will also have to test the entire flow. So basically, we have to test the merge sort and insertion sort as well, because it's a part of the same method. So this is why this is in direct violation with the open close principle. So this, our custom sorter class, is not closed for modification. So let us try to figure out a better way to implement the custom sorter logic such that it does not violate open close principle. Let us try to implement our custom sorter class again, but this time let us follow open close principle. So let us make sure our code is actually open for extension, but it is closed for modification. So as you can see, in order to incorporate the new changes, this time, instead of making changes directly in the sort method, I try to create new classes for my sorting algorithms. So I basically have an interface of called sorting algorithm, which basically has a sort method, and then the algorithms themselves implement the interface, and then I have the logic of the sorting algorithm here, moved here. Similarly, I can have the same story for merge sort and have the same story for quick sort as well. And now let's go back to the main method. And this time, a sorting algorithm, instead of taking a string as an argument, it basically takes an instance of this the sorting algorithm itself. So here, if we want our custom sort object to actually sort it using quick sort, all we need to do is pass a quick sort object to it. And similarly, if we want our custom sorter to actually sort it using merge sort, all we need to do now is to pass a merge sort object to it, and it'll take care automatically. And tomorrow, if say a new requirement comes up where we need to incorporate another sorting algorithm, all we need to do is just create a new class. Say the new sorting algorithm we need to incorporate is genius sort, and all we need to do is do the exact same thing as we did for our other sorting algorithms. So we need to do the exact same thing, and we just need to pass in the genius sort instance here. Our code will basically pretty much remain unchanged. So this way, our code is much more maintainable, and it makes the job of testers a lot easier since we don't need to test the whole flow. If we want to add a new sorting algorithm, we can basically just test the new sorting algorithm and just make sure this works. This logic is correct, and we don't need to test the entire flow. So that is the benefit of actually following open close principle. And by following open close principle, we actually have taken care of another very important design principle as well, which deserves another video, and it's called the single responsibility principle. So we've also ensured that each of the class now has a single responsibility. Earlier, we were dumping the entire sorting responsibility for all the algorithms into one sort method, and that was causing problems. And now here we've created separate classes for the same, and each class now has a single responsibility, and this also follows open close principle as well. While it is true that open close principle is indeed one of the most important design principles, and knowing that can help you make your code very much extensible to new requirements in the future, it's also important to keep a small disclaimer in mind. And this is from Head First Design Patterns book. And it says, be very careful when choosing areas of code that need to be extended. So, blindly applying open close principle everywhere is also sometimes wasteful and unnecessary and can lead to complex, hard to understand code. So, just wanted to end this video with a small disclaimer. Thank you for watching.